Hi everyone, welcome to a new video, Kaggle Success, 3 techniques to boost your ranking. So in this video, we will cover 3 important topics related to machine learning, and we also gonna highlight binary prediction with a rainfall competition. This competition is under playground series problem anyone can solve as a data analyst or data scientist. So let's get into it. So basically, when we talk about 3 techniques, they are a common issue in Kaggle competitions, which is overfitting. Overfitting is perfectly related to training subset. However, when you try to apply it on the test subset, there is actually a low accuracy rate. Or as in this competition, if we are talking about the binary prediction, then the ROC curve has low percentage. This happened due to overfitting. In the last video, I touched over overfitting issue and variance term, so feel free to check out that the machine learning model is failing to generalize on new unseen data. And to overcome this overfitting issue, we will learn in this video feature scaling, hyperparameter tuning, and cross-validation. How we can do this? Basically, this supportive technique makes the machine learning model perform perfectly well and achieve high performance. It also improves model generalization as well as reduce overfitting, which is the main problem we usually have when we deal with the Kaggle competitions problem. Additionally, we have to ensure that the machine learning model is performing well on a new unseen data. We mean here is that the testing subset, bias, variance, trade-off. Basically, these 3 supportive techniques, they help in finding a balance between underfitting, high bias, and overfitting, high variance. Let's start with feature scaling. Feature scaling, we have 3 types: normalization, standardization, and min-max scaling. Normalization is basically rescaling values to a specific range, typically between 0 and 1 or -1 to 1. On the other hand, we have standardization. There is a function in a scikit-learn which we use is a standard scaler. By the way, standard scaler, we usually use it a lot in machine learning pipelines when we create pipelines. I will highlight and cover this point in a future video, no worries. So basically, standard scaler transforms data to have a mean of 0 and a standard deviation of 1, which is z-score normalization. This technique is pretty useful for machine learning algorithms such as support vector machines, BCA, logistic regression. BCA is one technique or algorithm we used in dimensionality reduction, and I'm covering this too as well. And mini and max scaling, which is in scikit-learn, is mini-max scaler, rescales values to a fixed range between 0 and 1 or custom range. And I have highlighted the 3 equations for more guidance. I believe that the standard scalar equation is pretty common way, and xi here represents the original feature value. And there are some points I want to highlight when we talk about feature scaling, that usually when we use mini-max scaler, because we can't apply normalizer and rows based, that can lead that each row has its own scale. And we want the features to have the same scale that helps in predicting the target response and avoid overfitting, which is the primary problem we want to handle. And among any other issues, of course, we don't want different weights on different features. Mini-max scaler is applied column-wise. On the other hand, normalizers is applied row-wise. Minimax scaler works best when the data isn't normally distributed. Between mini and max scaler and the standard scaler, Standard scalar is much less affected by outliers, and usually we use standard scalar all the time. In scaling, we are changing the range of the data, while in normalization, we are changing the shape of the distribution of the data. And I have found these two beautiful blogs. Feel free to check them out. The first one is on Stack Overflow. The second one is on Medium. I will add both links down below. Feel free to check it out. We have hyperparameter tuning. Hyperparameter tuning is the process of selecting the best combination of hyperparameters, aka features, to optimize a machine learning model's performance. And there are two types I want to cover in hyperparameter tuning in this video. Both of them are seeking to find the best hyperparameters for a model. Hyperparameters meaning we define the features before training the model. If we are defining the features during the model, then we call them just a parameter. The two types of hyperparameter tuning techniques. The first one is grid search, is a way to find the best hyperparameters by testing every possible combination, but it's not feasible in high dimensionality space. The second one is random search. Basically, random search picks random combinations of hyperparameters instead of testing all of them like grid search. Grid search is kind of manually defining until you find the best suitable values. But the random search is quite randomized, or I would say quite automated somehow, but is still much faster and more efficient, especially when there are many hyperparameters to tune. So in this side, where I highlight how hyperparameter optimizations work, I wanted to give you an idea of like workflow when we deal with hyperparameter techniques. So basically, we choose a suitable machine learning model we want to optimize, let's say random forest. Then define hyperparameter tuning type and search strategy. You can find that on scikit-learn. Random forest and hyperparameter in case you will use random forest with a random search. Then set up cross-validation scheme. I will cover cross-validation in the upcoming slides. Then select evaluation metrics and the score function. Let's say we will use accuracy and ROC curve because usually Kaggle competitions are evaluated, most of them with ROC curve, and yeah, ROC curve is. And moving on to the most common hyperparameters. These are the hyperparameters we define in case we will use this technique. So the first one and most common one is learning rate, that represents the step size during gradient descent. Then we have C. C stands for the penalty value. Decreasing the C value makes the margin between classes larger, thus ignoring more noise, but also making the model more generalizable. A best value can normally be found in the range, as highlighted in this function. Then we have max depth. Usually it's between range 1 and 16. Represents the maximum number of splits on features. We use max depth with random forest decision tree. Setting it to a number below 0 allows the maximum possible number of splits, usually risking overfitting to data. Then we have gamma. Gamma can be used with decision tree models such as XGBoost, CatPost, LightGPM, and in support vector machines model. And in each method or in each models, it has a specific meaning. So in this, with the decision tree models, it specifies the minimum loss reduction required for a node to split, because again, it's a decision tree models. Higher values makes the model more conservative. When it comes to SVM models, it controls how much influence a single training point has in the RBF kernel. Higher values make the decision boundary more complex. Decision boundary is also associated with SVM or support vector machines. If you remember, you can like search for SVM and decision boundary. You'll see that it's when we describe SVM, we always describe points on between axis, x-axis and y-axis, and there is like a straight line that filter or that make divide the points, the red points from the blue points. I want to share it with you guys. So back again, we have, yeah. So if I want to say and highlight the difference between hyperparameters and parameters, I would say that any quantity that's set before the training process is a hyperparameter. Any quantity that model creates or modifies during the training process, then we call it as a parameter, okay? And finally, with the third and final technique in this video is cross-validation. Cross-validation is a method to test how well a model will perform on a new unseen data by splitting the dataset into multiple parts for training and testing. So as you can see here in this graph, we have the training. Let's assume it's 80% and validate it's 20%. So our model, what the cross-validation technique will actually divide the whole part into this small chunks. Okay, so we have validate, train, train, and train, and then train, validate, train, and train. We do all this and then calculate the score. Score is basically we take the average score of the 4 parts, okay, and then we find the best. We can use it to train our model and get high accuracy. So basically, among all the 3 techniques, which whether it's a feature scaling, hyperparameter tuning, or cross validation, our primary goal is avoid overfitting, avoid underfitting, and get high accuracy, high percentage when we deal with the evaluation matrix. That's the primary goal of these 3 techniques. And our approach is not limited to these 3 techniques. It can also include additional features such as feature scale, feature importance, feature engineering. That's basically what we try to achieve here. And moving on to cross-validation types. So basically, cross-validation types can be k-fold and stratified k-fold. K-fold is a method usually to recycle the data and use it as a training and validation as well. It consists of training and testing several models on different portions of the data, as you can see here. That's what k-fold represents. Then the other technique, similar to k-fold, but preserves the percentage of symbols for each class. In the second video, part 2, I will implement these 3 techniques on the binary prediction competition. So it can give you like a baseline for your project, and you can participate in this beautiful competition and try to implement it using techniques you have learned and try different methods and models, and you can share down below in the comment section. So combining hyperparameter tuning and cross-validation ensures that the machine learning model will perform well on new unseen data. I want to give you some intro when it comes to the competition. So competition name is Kaggle binary prediction with a rainfall dataset, and machine learning algorithms I'm gonna use, which are logistic regression, support vector machines, decision tree, random forest, cat post, and XGPost. And supportive technique, feature scaling, hyperparameter tuning, cross-validation, what we have learned today. And the evaluation metric for this competition is ROC accuracy score. And when it comes to the video, it will be muted, and you will see my comments and doc strings on the screen. If you have any information for me regarding the video or any questions regarding the code implemented, feel free to drop your comments and I will respond on them. Thank you. And that's it for today. Thanks for watching. If you find my content useful, don't forget to like this video and subscribe. Thank you, and I see you in the next video. Bye.